Hey guys, it's Mr. Fourth Dimension, and we're doing a little bit of work on the push reset series right now. Um, so just to give a quick description of what's going to go on here, I'm working on reprogramming a game called Push. There's a link in the description if you want to check out a demo or any other information on the original version. The reprogramming is basically because there's a lot of rough edges in the code, and I would like to be able to port it, but it's not really set up in the old version to be ported too easily, so I figured this was a better way to go. Plus, I don't want to open source the old version because the code is not, it's just not good learning material. People shouldn't code the way I did anyway. So this is my way of making up for the fact that I'm going to open sourcing the game's code. Okay, so last we left off, we'd just gotten some basic movement stuff done, and it was still pretty rough, so I'm going to show you where we are now. You can see that the movement's a lot more stable, and I've also added pushable blocks. These are working just the way they normally work in the game now. I'll show a little bit about how that code works. And this red thing down here is a pit, and so I'm going to push in block into there, and you see that they'll annihilate, and now I can walk around here, but there's no push block. Now I also have this key Alt that if I hit Alt it resets the game. Now there's a couple problems to deal with. First of all, the collision thing, and collision is loosely not normally what collision means in a game, but the idea of collision and push hasn't been properly implemented yet. So the way that collision just got resolved isn't as clean as I'd like it to be. So there's stuff to work on there. There's also the issue that these are entities right now. So the push block is an entity, the pit is an entity, and they just sort of are allocated directly, and when that happens right there, they're no longer in play, but they're not deallocated. And there's a lot of things in the game that, like especially bullets, if you've played, you'll know that they get created and destroyed repeatedly throughout a play session, and that shouldn't, so basically what we need is we need the ability to reuse old spaces when we create new entities, as that is what happens with bullets. So that's one other issue that we'll be working on in upcoming sessions. I don't know if it'll be on video or not. That's one of the things to work on. And then there's this last problem is when the player walks into the pit, it's supposed to annihilate him, which it does. And you can see that it leads to a bit of a problem. So we got to debug that. And that is where we will start. So let me show you first the code that I've made since last you saw. I don't know if the add entity stuff was here, but now the entity stuff is all basically set up. We have an add entity function that you just pass in the main variables for the whole program right now. Maybe there'll be an entity manager struct that I pull out, but right now it's just passing all of this in. It grabs the next entity available and clears it, sets its ID, and that's about it. And then the specialized versions are for adding entities that have special characteristics, like the player entity. You set its type, we give it a position, a direction, and you place it into the grid. And same thing with all of these. You give them their type. You set these to solid because walls are solid, but you don't need to set a direction for walls. Same thing with blocks. You set them to solid. You add all those to the grid when you make them. Pits are not solid, but they are a floor type, and that's important for later logic in the game. And then you add it to the grid. Then there's this move entity function, which moves something. The grid is basically, I think this was something else that it's basically made up of cells. So each cell is an array of a couple of pointers, or I'm not sure if it's pointers or what it is, but let's look at that struct. So a grid cell is it's four integers, which are indexes to they're basically the IDs of entities. So up to 4 entities, and whenever you add something to a cell, it gets put at the end. And this move entity function is basically just doing the work of seeing if this entity has already been placed in a cell. If so, it removes it from that cell right here, and then it adds it to the new cell. If that new cell is actually in the grid. If we move it outside of the grid, it does none of this happen. Nothing happens. Okay, so that is some of the movement stuff. There's a lot of stuff that I did, like the same input checks if 2 input structs have the same basic data. in them and all sorts of stuff that I did to clean up that movement. But the more interesting thing is this, what happens when there is movement, how the game does a step. So I'm going to explain this a little bit. There's and this is, explaining this is a good spoiler to the game. Just warning you, because you'll get to see how some of the logic works, which is part of the fun of the game, is figuring out all the logic. But there's basically a few steps to updating the game. First, there's this early state update, which I'm not using yet, but that's used for things like electricity, that does some stuff that doesn't have anything to do with movement, just updates its state. Then there's resolving pushes. So what a push is, the reason the game is even called push is because when I was originally coming up with the code, or at least one of the reasons this contributed to it, is because the game is based on, the logic is these things called pushes. So every block is not just push blocks, right? You imagine that the reason the game is called pushes because you push blocks, but really what's happening is every block, including the player block and like other blocks that move, all generate a push that is going to move them every frame. So when you push an arrow, you're generating a push. When you push an arrow key, you're generating a push for the player. There's also like the bullets that fly; they are pushed along each frame, based on which direction they face and stuff like that. So what happens is, first you generate all of the pushes, the ones from the player, the inherent pushes, and the absorbed pushes. You don't actually generate those. Those are results of trying to resolve the first wave of pushes. So then what happens is you say, look at, once you've generated all of the inherent and player-based pushes, you start looping through them, and each push struct basically contains which entity it wants to affect. I wonder where I have this. Push. Yeah. Which entity ID, an entity ID, which is the entity it's going to affect, and the direction it's pushing in. So let me just get back down to where I was. Here we go. So as long as there's something in this queue, this queue here contains all the pushes that need to be processed. As long as there's at least one to do, it'll keep on going through the queue. And at each step of the queue, or each step for each thing in the queue, it takes a look at the push. It takes the entity it's going to move, and it looks at the new position that that entity would move into, and then it checks that new position to see if there's a solid in the way. If there is, it says, look, store that solid into this ID here. Or if they're going off the edge of the screen, it sets the solid ID to -1. Now, if the solid ID is 0, because remember 0 is reserved, so no entity has the ID 0. If it isn't equal to 0, then that means there was no problem. But if it's not equal to 0, then either we're going off the edge of the screen or we hit a solid. And then what you do is you say, look, if I'm a player, if the entity that we're trying to move is a player, and we're not going off the edge of the screen, then we need to maybe notify that solid to absorb this push. Now, only if not every solid actually responds to absorbing a push. Walls don't respond; they're in walls, but blocks do respond. So, how that works out is, that's a bug in Emacs. Did anyone see that? Oh well, I'm ignoring it. So you grab the solid entity that you're running into, and you ask what type it is. If it's a block, then you generate a new push. You enqueue a new push into the queue, and this new push is in the same direction, and it's affecting the solid instead of yourself. And then whatever happens, right? So that's how a push block absorbs a push. And then this step here just says whatever I am, whether I'm the player or not, anything that was going to move, if it's running into a solid, it should stop. Now this of course isn't always true. A bullet doesn't actually stop just because it's running into a wall. It actually just completes the step and moves into the wall. So this logic isn't complete, but this is the basic idea, is if I run into a solid, and I'm something that should respond to solids, what do I do? And bullets don't exist yet, so we're not handling that case. And then there's, let's see, what is this? Oh, and then finally, once you're done like checking for solids and stuff, you actually set the next direction for that entity. So every entity knows the next direction it wants to move, as the direction the push ended up at. Now, the reason we have this whole main queue, secondary queue, we have an other queue here, and then after we've processed everything in the main queue, we swap it, and we say the main queue is now the other one, and we clear the other one, the new other one, because that's the one we just finished processing. And so all the, like, if the push block wasn't going to move before, and then we push it, now it's going to move in this direction, right? And then we process the queue again. Now, there's maybe a danger that this perpetually happens. Right now there isn't, because the only thing that can generate pushes is the player, and after the first wave through, the player, if the player has passed a push into the next queue, he himself is stopped, and he's not going to be generating any more pushes. So this can only actually happen once. But later on, this same idea is used for ice. If I'm running into a solid and I'm standing on ice, then what happens is I stop my current motion, but I try to move in the other direction. And there's rare cases where, and that by trying to move in the other direction, what I mean is you push your you generate a new push and put it into the other queue, and it gets processed on the next loop through. The danger is that in rare cases you can get stuck between two solids, right? If there's a solid on either side of me, then I'm going to keep on seeing that I'm running into a solid, and it's going to want to go the other way around. It's like a little, I don't know what you'd call it, like a little hole in the logic of push. The whole game is, for the most part, I'm really happy with the game's logic because of the fact that it's like so unified, and that like so many of the things are just rules that make sense. They follow this really tight law, but that particular case doesn't work. So what you have to do there is you have to say, look at the direction the player is moving, and if we generate a new push when we're on ice, right, and we generate a new push going the other way, if this new push is moving in the same direction that we were already moving, then it works no matter what, even if there was a solid there. So we need a special kind of push that says, I'm going to move even if I'm running into a solid, and that's what we use for things like bullets and for things like objects that are moving, like bouncing between two solids in one square, to resolve those. Okay, so basically that's how everything finds out which direction it's going to move, is it resolves this queue of pushes. And then once that's done, it just steps through all of the entities, and it says if their next direction is not stop, set their new position and move the entity. Now there's some optimization that might be done here. We might say we don't need to loop through all entities, and we can make a special list of the entities that are kinetic entities. That way we don't loop through walls and stuff, right? Because those don't move. Same thing with pits, ghosts. What else do you have? Ice. Like lots of entities don't actually need to move. Wires. So that's a thing to think about as we move forward. Because I think the original one had an optimization for that, but it was nutso crazy. Is because it defined a moving entity as a totally different like subtype, and I'm trying to avoid that this time because that made a bunch of headaches. But it won't be too hard, I don't think, to have a separate array of things that need to be moved. Let me check the time real quick. Not bad. Okay. So then we resolve collisions, and this is where we're going to spend most of our time today, is in this step. Resolve collisions works like this. You have a bunch of cells, and you loop through each one, and you grab all the cells. Now maybe there's a quicker way, and we can work on this too, of knowing which cells you're grabbing, because most cells don't even have any entities, and we're only interested in cells that have 2 or more entities. And so touching all like 360 cells or whatever it is, it's a little bit overkill. That isn't right. Why is that 25 and why is, well, this should be 24. Oh, that's weird. Anyway, yeah, I was just trying to think why does 360 make sense, and it's because this is supposed to be 24. So anyway, the point is, like, maybe while you're moving entities, you have a list of, like a stack of all of the grid cells that are length 2, or that have at least 2 elements, and then whenever something gains a new, any cell that ends up at any point during that process having at least 2, it gets added to that stack. So you'd still have a few cells in that stack that wouldn't actually need processing, but you'd have way less than 360. So that's an optimization though. Right now I'm just worried about the logic once you have the logic that happens after you have a cell that you know needs processing, so everything inside this if. What do we do in here? We look at everything in the cell and we resolve collisions basically one at a time. So if there's two things in a cell, we have these two loops, I and j, that are going to loop, both are going to loop over every element in the cell, every entity. If I and j are the same, we ignore that because we don't resolve collisions between like a self and a self, right? That doesn't make sense. But if I and j are different, then that means they both refer to a different entity within the cell. And so we grab both of them. All we really need is their type, because there's not much else in the game that matters in terms of what happens during collision. Their state matters, but not during the collision resolution, right? So we just grab type and we say, look, if we have type of this and this together, we respond with this. And now what is this doing? Well, we have this array of 4 booleans, and it's 4 because of the fact that a grid can have up to 4 elements, or entities. A cell can have up to 4 entities, and we're saying, like, if it does this object, basically the only thing that can happen is you can determine that this object needs to be destroyed. So if so, we set the kill me to true for that object in the array. So, for example, if type 1, which comes from I, is a pit, and type 2 is a player, which comes from j, then the jth guy, the jth entity needs to be destroyed. Now, if type 1 and type 2 are a pit and a block, they both need to be destroyed. And there's also a question you might have is like, well, what if the I happens to be the player and the j happens to be the pit? Then this wouldn't fire, but shouldn't it? Well, yeah, but we're going to do every combination with I and j. It's not just combinations, it's every permutation, I guess I should say. So I and j, it'll process I as the player and j as the player, and j as a pit, and also I as a pit and j as a player. So both ways get processed, and you just have to capture it once here. Also not necessarily the best thing to do, but that's what's happening now. And we're going to clean this up because there's a lot of ways you can make this logic cleaner in the game. And then, what you do is once you've figured out who needs to be killed, you just loop through everything and you destroy them, setting their entity type to ent error, and you remove them from the grid. And as I mentioned, we don't do any sort of deallocation. We don't mark their entity space as free to a system so that it can reuse it. So that's an issue to work on in the future. And of course, there's this step that I'm ignoring because it's not what we're doing right now. But the first issue is that apparently when we free the player, we get a problem. So let's think about that. The main reason that probably happens is because when we free the player, suddenly things that refer directly to the player stop working. And by that I mean, let's see, are there any things that happen? Because that all happens only if there's ever a motion input. But maybe some stuff happens. Let's see. That just handles input that way. If I'm not giving any input, none of that happens. So yeah, it looks like the only time it'll start, like right here, it's using this 1, which basically means the player. So in cases like this, you have an issue. But I'm not entirely sure why we have a bug. So what I'm going to do, I don't know if I've ever shown this, but I'm going to launch the debugger in Visual Studio. If I have shown this, then it's not the reveal that I think it is, but I think this is the first time I've typed dbg to open debugger in my little command line system. And, alright, we don't want to see this file, but so what can we do? So this is a file we haven't even been looking at. This is part of the engine, the Windows engine that runs it. You might be asking, if you're doing this reporting, why do you have a Windows-specific engine? Well, because one of the platforms I'm porting to is Windows, and I'll remake this for the platforms that I port to once it's working in Windows. But we're looking for, that's audio update. I think it's before the audio update. 132 go windowed. Yep, that must be right here. It is. Game step. Alright, so I'm putting a breakpoint there so that the program will break when it reaches that. Of course it won't because it's... Oh, there we go. And I can F11 to step into it. Oh man. Yeah, step into it. Stop. Okay, so there's some sort of disagreement that always happens between Emacs and Visual Studio in terms of whether they're synced. And I don't like that. And that's more on Visual Studio's fault in this case. But now we have the push file up, which is what we wanted, and we can run the whole thing. Get rid of the breakpoint, and I'm gonna make it break, and then we'll see what's causing it. So I'm gonna hit that first and do nothing. If I don't give any more inputs, does it break? I don't see anything breaking. Okay, now I'm gonna try hitting Alt. Okay, hitting Alt was fine, so hitting Alt didn't reveal a problem. Now I'm gonna try giving an input. I'm gonna try hitting up, and there we go. That's the break. So we have one of the tentative inserts. Interesting. Does not equal count. Grid cell remove. Means we tried to remove the player from the grid cell. Okay, interesting. So at some point we're trying to call stack. I think I know what it is. So we're trying to call move entity during this step where we're actually doing the moves on the first. Yeah, okay, I see it. So this is why we need a smarter system for destroying an entity. Because what just happened is it's trying to move an entity that doesn't exist. So what we need to say is, look, if this entity type does not equal ent error, right? Now that raises an interesting question too. If we're going to have gaps, are we just going to if over them and skip them, or are we going to have like a list of indexes that are the real entities? Not sure. We might have the memory space for the entities, and then the list of entities that exist, and then the list of entities that are moving entities that exist. And those would both be just arrays of indexes or IDs. And yeah, that fixes the problem. No more bugs with the destruction. So that raised a good idea, possibly, of these lists of which things are actually real. But we're not going to deal with that yet. Because first, I want to deal with this collision stuff. Collision resolution. So, as I said, there's a way better way of doing this. Right now we're just saying that we're going to have a list of cases. If it's this pair of things, then kill this one. If it's this pair of things, kill both of these things. There's some logic. There's more structure to the logic than that we can have. And the other game used it too. I wasn't sure if I would keep using it, but now that I'm looking at it, it looks like we will. So this is a good reason why wait, 2, 4, 6, 8, 9, wait, 2, 4, 6, 7, 8, 9, 10, 11, 12, 13. Right, so I said this has to be under 16, and it's only at 13. So we can afford another byte, which will be kill power. And what kill power does is it basically says everything can be ranked in terms of how dangerous it is. If one thing has higher kill power than another thing, then the other thing gets destroyed. And there's only a couple of... if two things have the same kill power, nothing happens. And if something has a kill power of -1, it is neither killed nor does it kill anything via that system. And what that lets us do... First of all, we can't just ask for entity types anymore, so we're going to change this to just asking for entities. Entity 1, entity 2, those will be pointers, like so. And then we're not going to grab the type, we're just going to say, give me a pointer. Oops, there we go. Okay, and that's got to say entity 1, entity 2. So the reason that the thing we have here won't work long term is because this is just a lot of different things. We'd have to have each type of bad guy, for example, I don't know what to call them, baddies, like the the red and green beetles and the red and green bats, they would each have their own type. So that would be 4 things that would look just like this for killing all of those. And then like you also need 4 things that look like this for killing ghost collisions with each of those baddies. And you would also need ghost player collisions. You would need all of the collisions with everything would be specified by pairs, and you have a sort of combinatorial problem, and a lot of things don't need to be specified that way. So, what we do here is we set a couple of questions. If entity 1 has a kill power higher than entity 2, well, first of all, let's make sure that these guys neither of them have a kill power of -1, because if either of them have a kill power of -1, then this rule doesn't apply. So neither of us have a kill power of -1. And then, under those circumstances, we also need to actually make sure that neither of them, how does this rule work? Yeah, it's like, if this is a floor, okay, I'm trying to figure out how to condense this into an if, and it's kind of hard. But what we could have is we could have a thing that says like, no kill rule equals 0, and then if we find any particular condition that says not to use the kill rule, then we don't use it, because that just makes it easier on me to think about the logic. Okay, so if either of them has a -1, the rule does not apply. If entity 1 is a floor and entity 2 is flying, or if entity 1 is flying and entity 2 is a floor, then there's no kill rule. I think that's all of the exceptions that I know of right now. Seems like all of the exceptions that I know of. So now, if not, okay, so we're going to invert that. Little idea here. This wasn't originally my idea, but it'd be nice to have a refactoring tool built into your editor that could rename a boolean and switch its logic for situations like that. Or rename any variable in general and not switch the logic if you don't want to. But if kill rule, then what you guys say is if entity 1 has a kill power greater than entity 2. Oh, there is another condition where we don't use this rule. Well, we kind of are using the rule. I'm not sure. Let me see how far I get into setting this up. If entity 2 has a kill power higher than entity 1, so what the way this works is if kill power from entity 1 is larger, then kill the second one, right? Set him to be. And if the other way around, set him. Now, in a sense, these are going to both get checked. These are kind of redundant since we're going to try every permutation. So we can take that out, right? In other words, if this doesn't catch it because of the fact that this guy has a lower kill power and this guy has a higher kill power, there's going to be another time where they are swapped and then it will catch this. So it's fine to just do it that way. Now, the other time, and because of that, that means that we are going to add another exception to the rule, and that is when they have equal kill powers, because that is another time where you trigger, if you're not using the kill rule to determine who kills who, then you're using specialty rules. And specialty rules are things like pits and blocks. So these are still special because this is asymmetric, right? One has to have a higher kill power than the other, so you can't have mutual annihilation between like a pit and a block. So it doesn't eliminate all of the combinatorial problems, but it gets us a little closer. And let's go to the add entity stuff now, because now we want to tell these guys about their kill powers. So yeah, we take this entity here, his kill power, I forget what the kill power of the player is supposed to be, but I think it's 1. I think he's supposed to do one of the weakest things. There is a 0. It's too much of a spoiler. I can't tell you what the 0 is because that's too much of a spoiler. The wall is the strongest thing. It's got a 10. Blocks are a 9. Because there's weird cases where a block might actually end up inside a wall. And pits are the same as blocks. That's why they have a specialty rule for mutual annihilation. So you'll notice that if the player ever ends up inside a wall or a block, he's going to have a lower kill power. If he ends up inside of a pit, he's going to have a lower kill power. If block ends up inside of a wall, it will have a lower kill power. The only time where we need a specialty rule is when a block and a pit are both in play. So let's see if we've maintained the same behavior. Oh, types don't work like that anymore. Entity 1 type, entity 2 type. Okay, that's all working well. Yep, that's still working. Let's reset the game. There we go. Yep, that's still working. So, collision resolution is looking a little stronger. I think I'm going to cut myself off here for this one. This still the matter of entity freeing and unfreeing, which I'd really like to capture. I'd really like to capture in it, but it's got to be done soon, so I might end up missing that one on video. Sorry about that. But hope that this has been interesting to some of you guys. If you like it, be sure to keep up and watching. You can subscribe or whatever. I don't normally tell people to subscribe at the end of my videos. It feels weird. But yeah, hope you liked it. See you guys next time.